Hello everyone. The purpose of this video is to go over the calculations that you need to do in this experiment. Now, some of the calculations are already done for you. For example, you don't need to calculate the momentum as the simulation will provide you with this value. We know if you want to calculate the momentum, for example, the initial momentum, you have to multiply the mass of the object by its velocity. So initial momentum for mass 1, which is this one here, will be simply the mass m1 times the velocity v1i, and this will yield 3 kilogram meter over second in the positive x direction. The same way here, if you want to calculate the final momentum for the first mass, p sub f1, this one here, the momentum is the mass times the velocity, so you have to multiply the mass m1 by the final velocity of the first object, which is this one. But you don't need to do these calculations since the simulation will provide it for you. You just need to know how those values came about. Now, the calculations you need to do start from question number 11, where you are asked to find the total initial momentum, which is this one here. Question 11, this refers to trial number 1 here, will be the sum of the initial momentum of the first mass m1, this one here, plus the initial momentum of the second mass in the first trial. So the sum of those two will give you the total momentum before collision. Now for question number 12, which is this one here, you are asked to find the total final momentum, which is the total momentum after collision. And this is on the first trial. So you have to refer back to table 1, and you need to add the final momentum of the first object, which is this one here, plus the final momentum of the second object, the second mass. This will give you the total final momentum, number 12. Question 13 asks you to find the total kinetic energy before collision. Now we know kinetic energy is equal 1/2 the mass of the object times the velocity squared. So here when you're asked to find the total kinetic energy before collision, so you're asked to find the sum of the initial kinetic energy of the first object plus the initial kinetic energy of the second object. So this is for question number 13. So in order to do that, you'll take 1/2 times the mass of the first object, which is 0.5 kilogram, times the initial velocity of the first object, which is 1 meter per second, and square it. And then you'll add the value that you will get to 1/2 the mass of the second object, which is 1.5 kilogram, time its initial velocity, which is negative 0.5, and you have to square the negative 0.5. And this is for trial number 1. So the values will come from trial number 1. This will give you the total kinetic energy before collision. Then the same thing should be done for question number 14. But instead of initial, we'll go with the final. This should be the final. And also we'll replace the initial here with the final. And initial here with the final. So for question number 14, you'll multiply 1/2 by m1, which is 0.5 kilogram, times the final velocity of the first object, squared, which is the negative 1.25 here, and square it. And the answer should be added to 1/2 times the mass of the second object, which is 1.5 kilogram, times the final velocity of the second object squared. So you have to take the 0.25 and square it and plug it and carry out the calculation. Now what you did for trial number 1, you'll do the same thing for trial number 2 for both the total momentum before and after collision and the total kinetic energy before and after collision. So everything you did for trial number 1, you'll do it for trial number 2, but of course you'll take the values from the first table using trial number 2. So this is how you'll do the calculations for question 11 to question 18. Now the same thing can be implemented on table 3 and 4 here, questions 23 to 30. Now for question 31, it asks you to calculate the change in the total momentum. And here it tells you use table 2 first, because table 2 is pertinent to elastic collision. And then you'll do the same thing for table 4 in elastic collision. So here you'll subtract the total initial momentum from the final total momentum. So basically, you'll subtract what you got here, which is the sum of the initial momentum, from the sum of the final momentum. And you'll do the same thing for the change in the total kinetic energy. You'll subtract the total initial kinetic energy from the total final kinetic energy. And what you did for trial number 1, you'll do it also for trial number 2. And you'll apply the same thing on table 4 here. And this will help you to conclude whether the momentum is conserved or not in both elastic and inelastic collision, and also whether the kinetic energy is conserved in the case of elastic collision versus inelastic collision. Now make sure in the last question here, where you show all your calculation, to follow the guideline. So you have to show the equation, plug the values, and so on. As I showed you here, for example, for the kinetic energy, this is the equation to find the total final kinetic energy. And notice that the equation has clear left-hand side that tells me what you are calculating. So this is the equation, then the equation should be followed with the calculations. So the final 1/2, and then you plug the value of M1, question 14. So make sure you specify the question clearly, question 14. So you plug the value of M1, which is 0.5 kilogram, times V final 1, which is negative 1.25 meter per second, all square, plus the final kinetic energy of M2, which is 1/2 the mass of M2, which is 1.5 kilogram, times the final velocity square of M2, which is 0.25. And you'll carry out the calculation, show the calculation of this part here, write it here, plus the calculation of this part, write it here, and then carry out the addition of those two. And of course, the answer would be in joules, because kilogram meter square over second square is joules. So write the answer. So make sure to show that on your calculation in these details. Alright, I hope you found this video educational. Please feel free to email me any questions you have. Thank you.